Okay, so we were looking at the aspects of having a, quiet please, having a different amplitude, having a different period, and even possibly having a different vertical shift in the wave. We talked about the amplitude yesterday, how far or how high or how low the wave falls above the rest position. And so the amplitude is going to be the multiplier of the trig function. We talked about a negative. When that coefficient is negative, it's going to reflect the wave about the x-axis. And then we started talking about the period and how the b value is going to tell you. Now be careful, the b value is not the period. It tells you how many waves in a normal period. If you want to find the period, you got to do either 360 divided by b, that'll give it to you in degrees, or 2 pi divided by b, that's going to give it to you in radians. So we did that first one with a half there. So that means you get a half a wave in a normal 360. Take 360 divided by half, you get 720 for the period of that wave. And so it's 720 degrees long, would be one wavelength or one wave. Second scenario here, second example, is when the b value is 2. So what we're saying here is we're going to get 2 waves in the course of every normal 360 for a sine or cosine. So again, if you were looking to find the value of the period is going to be 360 divided by that 2. So in this one, we end up with a 180 degree period. You should be writing this down, or to people that are in another world. Okay, so your period is 180 degrees. You will get numerous questions on the test as to what is the period of a wave. And you should know how to give the answer in both degrees and radians. So the period of this wave is 180 degrees. So there's one full wave in every 180 degrees. So if we were to graph this wave, I already have the pattern there on your paper. So I'm just going to take vertical dashed lines and mark it out at 180. Noah. Remember, the number out front is the amplitude, and then the number in front of the angle is the b value, which helps you determine the period. So, you know, this one has just a 1 in front of the cosine, so it's a normal amplitude. So ask your question again, make sure I answered it. Okay, all right. All right, so we're looking at a wave in every 180 degrees. So what are you going to do? Again, you should be thinking the pattern. And obviously you're going to need to have these patterns memorized. They're not hard. There's nothing hard about the pattern, but you do need to have it memorized. So you look at this wave and you say, okay, I have a wave, a full wave at 180 degrees. What do we need for a full wave? Let me go up to the top again. Oh, let's see. Nah, I thought I had it up there and I don't. So, you know, I'll just use the period that the pattern that's here. So again, in a normal 360, how does the cosine start? It starts at the maximum of 1, and we're still starting at 0, and so your first point is going to be at 1. Normally, don't do this on your graph, at the first quarter mark, the pattern is at 0. Well, our first quarter mark is right here. And so now we're going to be at 0 there, right at our first quarter. Can you see what I have here? I have first, mid, third, and then end, right? There are 4 lines in between the 0 and 180. So if you look at the pattern, halfway on the pattern is down at the minimum. So halfway for us is going to be at the minimum. At the 3/4 mark of the pattern, it's back to rest or 0. So at our 3/4, we're back to rest at 0. And then at the end, we're back up at a max. Now, don't do this next thing. I just need to show you something. So everybody look at the screen. This is what I saw from your papers that you turned in yesterday, which, by the way, were quite poor. And I've been doing this for 29 years, and if I were going to rank them from 1 to 29, they'd be right around 29. I'm just telling you. From all the classes I've ever had, that's where they'd be. Some of you guys did this. This is what yours would look like. You see this, and you see that, and that's not what the cosine wave does. It does not go fly off into space. And if you write it like that, then you're going to be wrong. All right, that is not the case. As you can see from the pattern, you see that downturn with the arrow. Do you see that downturn with the angle, with the arrow? That's what the cosine does. So again, this thing, now you can draw it in the right way. And I'm just stopping right there because we're going to continue in a minute. Kind of missed my mid a little bit, but such is life when you're drawing on an electronic device. So I'm just going to repeat this pattern one more time from the 180 to 360, right? We have another period of the wave. Because when does this wave repeat? Every 180 degrees. So again, at the first mark, it's at a max, and it's there already. At the first quarter, it's at 0. At the halfway point, it's at the min. At the third quarter, it's back to 0. And at the end of the wave, it's back to a max. And now you can finish drawing your wave. We're really getting 2 waves per 360 degrees. And that's what we should have expected. A period of 2, we're going to get 2 waves in a 360. Did I use an XY chart? No, and I'm telling you, I'll tell you again, try to remind you, here's what's going to happen if you use an XY chart. If you just use an XY chart and you don't know the shape of the wave, you're just going to get these random points and you're not going to know how to connect them. And normally what's going to happen is you're not going to have enough to connect them. And so you need to graph these using the pattern and using the fact of what the period is and what the amplitude is. That's the whole design of yesterday and today. All right, so let's keep going. Second page. Okay, so again, what is B? The number of waves in every 360 degrees. I'm sorry, doing the tangent now. So let me back up here. In the tangent, it's the number of waves in 180 degrees, or every pi radians. The tangent, as I said yesterday, is a little different. So if you were asked to find the tangent period, you've got to go 180 divided by B, or you got to go pi divided by B. Next year in advanced math, hopefully you'll do a good amount of those. I'm not going to give you many just because it's a little different. I don't want to confuse you, but that is the case. The reason is the tangent repeats every 180 degrees, whereas the sine and cosine every 360. All right, that is the case if you had to find the period of the tangent. You've got to go 180 divided by B. So it's the number of waves in every 180, or pi divided by B, number of waves in every pi radians, which again equals 180. All right, D is the vertical shift. We've talked about this before. We've talked about vertical shifts. Look, think about a function. Think about an XY chart. You put in a value for X and you get out a value for Y. Well, whenever you have a number tacked on to everything else, what are you doing? You're making the outcome 1 higher every time. No matter what number you get, you're going to increase by 1. If you get a 0.6, it's going to be a 1.6. You get a 0.3, it's going to be a 1.3. Instead of getting a 0.8, it's going to be a 1.8. Instead of a negative 2, it's going to be a 0.8. All right, add 1 to that. Or negative 0.2, it's going to be a 0.8. Everything you get is 1 higher. So what does it in effect do? It shifts the wave up 1 higher. So as we already know, a positive D is going to shift it up, and a negative D is going to shift it down. We've done this already with many other functions. Vertical shift. Pretty easy concept. So in this situation, right here, you've got the pattern again for the sine. And we're going to shift this wave up 1. So what I normally do is I put in a dotted line for the new rest position, the new 0 position. And I went up 1, right? I moved this black x-axis up 1. So now I'm going to do the sine wave right here. Right? So how does the sine wave start at 0? It's at the rest position, only the rest position is 1 higher, right? If you were to put it in 0, the sine of 0 is 0. 0 plus 1 is 1. So now instead of at 0, we're at 1. At the first quarter mark, the sine is usually at a max. Well, we have to go up 1. Up 1 from 1 puts you up at the top at 2. At 180, it's at rest. Our rest is now at the 1 spot, so we're right there along that new axis. At 270, the 3/4 mark, it's at a min, so we're down here at the bottom. And at 360, it's back to rest, and so you're back to 0. So if you now connect the dots, you should see the sine wave simply elevated by 1. And that is the case, right? The whole wave shifted vertically up 1. Vertical shift. If that were -2, the whole wave would be shifted down 2. If that were a half, the whole wave would be shifted up a half. If that were -3/4, the whole wave would be shifted down -3/4. It's a value tacked on after everything else is computed. So it's going to move the wave positive value up and negative value down. Again, we've been through vertical shifts before. That's not a big deal. All right, so you guys got to get good at figuring out amplitudes, periods, and vertical shifts. All right, so just do A and then stop. Figure out the amplitude of A, the period of A, and the vertical shift of A. Shouldn't take you but a minute. All right, Shane, what do you got for the amplitude? All right, and hopefully everybody agrees the amplitude is 4. This wave goes up 4 and down 4 from the rest position. Let's see, somebody that was here yesterday. Amma, what do you have for the period? Not correct. Mitchell, what do you have for the period? How much? 60. So if we're doing degrees, you would have gone 360 divided by the b value of 6. And 360 divided by 6 is indeed 60 degrees. If you were doing radians, you would do 2 pi divided by 6, and you would get pi over 3 radians if you were doing radians. Again, you should be able to do both, Alex. 180 is for which trig function? All right, did we do the tangent? We did the sine. Remember, the sine is every 360, the cosine is every 360, the tangent is the only one that's 180. Vertical shift. Grayson, vertical shift? What do you mean by negative? You got to tell me up or down. Down 2. You got to say up or down in the amount. That's how we've done all of our vertical shifts all throughout the course. Because again, if you say -2, I don't have confidence that you know whether that's up or down. So just say up or down from now on. All right, go ahead and do B. What about B? Give the amplitude, give the period, give the vertical shift. Amplitude, period, vertical shift. Anna, amplitude. How many put 2.5? How many put -2.5? All right, all the 2.5 people are correct because it's the absolute value of the A. Does Anna remember what we looked at yesterday? That's why I called on Anna. All right, so 2.5. Remember, the negative tells you that the wave is reflected about the x-axis, but the amplitude itself is always positive. Amplitude is always a positive value, okay? All right, once you see that, hopefully you're okay with that and you get it right from there on out. Brian, period. Okay, if we went degrees, it would indeed be the 360 divided by the 3. There's 3 waves in every normal 360, which means each wave is 120. If you went radians, it's going to be just 2/3 pi, right? 120 degrees or 2/3 pi. Vertical shift, Andrew? Up 4. All right. All right, do C. What about C? All right, Raina, what do you got for period? 4. Did I say period? Amplitude, and you gave amplitude, yeah, because I was thinking that too. All right, Andrew, what do you have for a period? Okay, so 360 divided by a half, right? Is that what you did? Okay. 360 divided by 2 is 180, so definitely 360 divided by a half can't be 180. Again, if you were doing elementary, you would invert the second and multiply, is what you would do. So it's 720, right? 720 degrees. If you were doing radians, it would be 4 pi radians. And the vertical shift, Shane. Didn't get it? All right. Vertical shift, Alex. Yeah, there's none. There's none. There's no number there. There's no vertical shift. Noah? No. 1 is, that's a vertical shift of 1, right? Right? Because it's not a coefficient, no, it's actually a number tacked onto everything. So, we could have written it like this if we wanted to, but that's kind of boring, right? So there is none. All right, or 0. If you put 0, that's fine. Okay, do the last one. Save amplitude. 1, right? Save did the absolute value of 1 and got 1, of -1 and got 1, so that's good. All right, period. What is the period of this? Let's see. Let's pick on, how about Aaliyah? Aaliyah, what do you have for a period? All right, so sounds like Aaliyah did 360 divided by 6/5. Again, if you invert this, it's going to end up putting the 5 in the top, right? Because it's going to be a 5/6 times 360. 6 goes into 360 60 times, and so 60 times 5 is 300 degrees. If you were to do radians, then it's going to be 5 pi over 3. Okay. So how many got the period correct? Again, it's just don't let the fractions cause you issue. It shouldn't be that hard. All right, vertical shift, Sammy. Up 8.3. Right. Again, you're definitely going to have to do that on Thursday's test, no doubt about it. You're going to have to do that on homework tonight. All right. So let's go ahead and use the pattern to graph. Okay, what we're going to try to do is tell you what amount of degrees you want you to graph the wave within. So in this case, we're saying, hey, go between 0 and 360 degrees. If you're going to graph these, you're going to first figure out the amplitude, you're going to figure out the period, you're going to figure out the vertical shift, and that's how you got to start these. So go ahead and fill in the amplitude and the period and the vertical shift, and then we'll go from there. Amplitude, period, and vertical shift. Right, and hopefully you said the amplitudes too. The period is 120 degrees, right? There are 3 waves in every normal 360, and the vertical shift is none. Okay, here's how I graph these. The period is really the key to setting everything up. Now, by the way, there's one thing we don't do in this course, and that's the horizontal shift. The algebra course used to do it in the past, and when they revised it, they didn't. You guys will get that in advanced math. But we don't do the horizontal shift. There is a way to do that. But thankfully, we don't have to worry about it. So we're looking at the period. I'm noticing what trig function I'm dealing with, the sine. By the way, you had to know that to figure out the period was 120. All right, so here's what I do. I take a vertical line at my starting point of 0, and I go either 4 or 8 lines and put my next vertical line. I'm going to go 4. 1, 2, 3, 4, and put my next vertical line in. That's going to be one wave. And because my period is 120, the end of this wave has to be at 120, and I'm going to put the 120 there. So the way you set these up is the key. If you set it up correctly in the beginning, the rest becomes easy. So again, why did I choose 120? Because the period is 120. I need a complete wave. Why did I choose 4 lines? Because remember, our pattern has a beginning, it has a first quarter, second quarter, third quarter, and an end. So it's real easy if we do 4 lines. Okay, the other thing I do is I have to deal with my amplitude. My amplitude goes up to 2, so I'm just going to go 1 and 2. I could go half and 1 and 1 and a half and 2. I'm just going to go 1 and 2. Negative 1 and negative 2. I can't believe how many of you tried to turn in graphs. You had the horizontal axis was not labeled, and the vertical axis was not labeled. What in the world garbage was that? That was garbage. That was horrible. I got to tell you, all that is just pure garbage. You got to tell what your axes are. You got to label your axes. All right, so we're up to 1 and 2. If you want, I used to do this, is just put a little vertical line at the top. And I like to put a little vertical line at the bottom. Just makes life easier. And now I'll continue on with my period. So that's to 120. I'm told to graph through 360. So I'm going to go another 4 lines, right? 1, 2, 3, 4. And what number is going to go down at the 4th line? Say it if you know it. I just went 4 more lines, right? 1, 2, 3. And what number am I going to put for the degrees at the 4th line? 240, right? So we're at 240. I'll put another vertical line there. And then we've got to go all the way to 360. So I'm going to go 4 more. 1, 2, 3, 4. And that's the 360 mark. And again, I'll put a vertical line right there. All right, so off the pattern, you should know how to graph the sine. So at the start, class, where's the sine? At what? At 0, right? Or at rest. 0 if there's no vertical shift, rest if there is a vertical shift. At the first quarter, where is it? Max. And for us, where would the max be? 2, right? So we're right there. Midway through, where's the pattern? 0, so we're at 0 at rest. 3 quarters, where's the pattern? Min, so we're down at the min. And then we're back to rest. And again, supposed to try to make a smooth curve. And that's the first wave of the 0 to 360, right? And now just finish it off. Just now take that thing and keep going with the pattern. All right, I'm at 0, max, 0, min, 0, max, 0, min, 0. That's it. Just finish the pattern. Once you get 1 and you've got it all marked off, it's easy to finish the wave. And there we are. Noah. Put what 2 also at the top? What do you mean by the top? You mean up here? Yeah, as I said, when I did the scale 1 and 2, I could have done a half, 1, 1 and a half, 2. mean, if you're making the scale, then you can make it where you want. Oh, by the way, that reminds me, I saw a scale like this. All right, so look out here. This line was 1, and the next line was 4. Is that a usable scale? All right, 1, 4. Yeah, that's a creative counting issue there. Right, you can't do that, obviously. That's ridiculous. Your scale has to stay uniform. But yeah, you could have gone a half and 1 and 1 and a half and 2. Not a problem. Other questions on that? So again, let me recap. Doing this stuff up here, if you're not told to do it, you should do it, because it's what tells you how to lay out the graphing of the function. The period is what you got to get marked off, because you have to know how many degrees for a complete wave, because you follow the pattern within that period. You also, of course, have to take note of the amplitude, because you have to realize how high and how low the wave goes from the rest. And if there's a vertical shift, you've got to employ that, because you have to see if this thing is shifted vertically at all. Right? Let's do one more example. All right, so right off the bat again, figure out your amplitude, figure out your period, figure out your vertical shift. Andrew, what do you have for an amplitude? 1/2 is the amplitude. Shane, what do you have for a period? Okay, so if we were going degrees, it would be 720. But I notice here I've got radians, so I'm going to do it in radians as well. So one wave is 4 pi. And then vertical shift, Joe? Just like any other function that we vertically shifted in the past. Say again? Nope. Andrew Tabor, vertical shift? Down 1, right? Down 1, the vertical shift is the number added to the function or subtracted from the function. Okay. So that's where we're at. We've got all that figured out. Okay, so I know one wave is every 4 pi. This is a long wave, right? It's stretched out, and I have to decide with this. Okay, so how am I going to make my graph? I could do this. Don't do this yet. I could go 1, 2, 3, 4, and go 4 pi right here, and you can. But that's going to scrunch everything up, and really this wave is elongated. So I'm going to go 8 lines and put my 4 pi. 1, 2, 3, 4, 5, 6, 7, 8. And here, I'm going to do it both in degrees. Let me go red here. I'm going to go both in degrees and in radians. 2, 3, 4, 5, 6, 7, 8. So this is 360. Oops, 720. Or 4 pi, right? Vertical line, because that's one complete wave. Vertical line, that's one complete wave. Okay, this is the way I do mine. Once I have the end, I just go to a half. So if I'm 8 lines there, 4 lines is halfway. 1, 2, 3, 4. Half of 720 is 360. Half of 4 pi, I'm going to do it above the line here, is 2 pi. I'm going to put my radians above. It'll work better because of the way our function is. Okay, and now I'm going to do the quarter mark. Half of 360 is 180. Half of 2 pi is pi. I'll go through as well on the right-hand side and go with the midway mark there. And that's going to be what, 540? 360 plus 180, right? 360, 460, 540. And pi, 2 pi, so that's got to be 3 pi. Okay, also notice they want me to go back to negative pi over 2. How many degrees is that? Somebody raise their hand. How many degrees is negative pi over 2? Anybody have it down yet? Aaliyah, thank you for raising your hand. Not negative 270. Who else? How many degrees is negative pi over 2? Meredith? It's negative 90. Negative 90. Remember, you could multiply by 180 over pi. The pi's cancel out. 180 divided by 2 is 90, negative 90. Guys, if you're not confident yet, just hold on for a second. Let me just do a quick aside. Sneeze coming. Excuse me. Look, if you're not confident yet that this is 2 pi, 360 degrees, and this is pi, 180, and this is pi over 2, 90, and this is 3 pi over 2, 270, you haven't been looking over your notes enough, I'm just telling you. Again, I know you're not used to thinking in radians, but that's a pretty easy concept to deal with. And so you should know pi over 2 is 90. All right, anyhow. So I know I have to go backwards that amount. So I need to label some amount of degrees or radians in the back. So I'm just going to look right here. Look, I'm looking and saying 2 marks is 180. Therefore, I'm going to go 2 marks to the left and go negative 180 or negative pi, right? And we'll finish with the back at the last part. Okay, so far I've done everything with the period. Let's start dealing with the amplitude. Got to start dealing with the amplitude. Well, the amplitude's a half. That's pretty small. So you know what? I'm just going to start. I'm going to use halves. Half and 1, that's all I need. Negative 1 half and negative 1, that's all I need. You can put more if you want, but that will take care of it. Now there's one other thing I got to do. I got to deal with this vertical shift. And after I do, I'll see that I might even need one more mark. Let me go ahead and put in the vertical shift. Again, I put a dotted line. You can put a solid line if you want. But remember, this is the new rest position. So once I look at that rest and I look at the amplitude, don't I need to go a half above that rest and a half below that rest? So I'm just going to put a negative 1.5 because I know I've got to go down that low. So this next step you can do or not do. Again, I like to put a dotted line at my max and a dotted line at my min of my amplitude, right? I went a half above the rest and a half below the rest. You don't need to do that, but I like to do that. It just keeps me on the right place. I've seen students know what they're doing and just get off a mark because they went either 1 mark low or 1 mark high just because they made a mistake. But usually when you have the vertical lines, you're in better shape. Okay. Now we're ready to do the cosine. And again, you guys have the pattern to look at. I can't show the pattern and show what we're graphing at the same time, but you guys have that on your paper, right? And look, come Thursday, that's got to be in your brain because it's not going to be on your paper. And it's not hard. It is 4 marks. Whoa, really hard stuff. 4 marks. I'll never memorize that. Memorize it. All right, so here's what you're thinking. How does the cosine start? It starts at the max. Where's our start? Right here, right? Start at the max. Hopefully you agree. Where is our first quarter mark? It's at pi, right? Or 180 degrees. So at the pi 180, go to the rest position. Doing the cosine. I'm looking at the pattern. I know the pattern. You guys are looking at the pattern. At the halfway point, where's the cosine? It's at a min. At our halfway, it's 2 pi or 360. I'm going to the min. At the 3/4 mark, where's the cosine? It's at rest. At our 3/4 mark, 3 pi or 540, I'm going to rest. Where does the cosine end up? at a max. Where's ours going to end up? At a max. So again, when I do this pattern, I'm just going to try a smooth curve. All right. Oh, Kool-Aid. All right. I'm getting ahead of myself and going too fast, and I apologize. You guys probably drew all that in. I meant to show you guys how to reflect, so I wish somebody would have helped me along the way. This is a reflection. Sorry about that. But you always have to be aware of those negatives. So you guys probably already have that drawn in, right? All right. So I'll tell you what, let's just cross that off and we won't do the reflection. If you were going to do a reflection, though, everything would have to be backwards. All right, so being you got it drawn in, I'll just leave it. But if that's a negative, where you started at 0 would still be 0. Where you went up, you're going to go down. So I started at 1, or at the max, I would have started at the min. Rest would have still been at the rest. Where the min was, it would be a max. Where the rest is would still be rest, and where the max is, it would be a min. All right, so this is what we did. I'll just show you real quick. It would have looked like this if we did it the way I wrote it, right? It would look like that. Reflected about the axis. All right, my bad. Sorry about that. I don't want to confuse you, so we'll just leave it the way we did it. So again, we're disregarding, right? Disregard the reflection. Treat it like it was a positive. Okay, how in the world are you going to do this last part? Okay, so if I'm at a max right now, right, I got to go back here because I have to go backwards, correct? Going backwards. So that point right there is going to correspond to this point right here. And I have to look at what the wave does backwards. So if I went 2 marks, I'd be there. So if I went 2 marks, I would be right there. Do you agree? However, it only wants me to graph to negative 90, which is right there. So I'm just going to make the line head toward that point, and I'm going to stop right there. Does that make sense? Negative 90? Because I got to graph it from negative 90 or negative pi over 2 up through 720. And so I simply looked at the pattern and did it backwards for 90 degrees. And again, you don't really want to keep going because it asked you to only do negative pi over 2 to 4 pi. So let me recap. You got to figure out your period. That's going to give you one complete wave. Got to take note of your vertical shift if there is one. That's going to give you the rest position. Your amplitude is going to go up from the vertical shift or the rest, that amount, and down from the vertical shift, that amount. Go ahead and put your pattern within your one wavelength, and then use your pattern if you need to do additional wavelengths. That's the concept, and that's what you got to get down. Questions? And again, if you have a negative tonight, reflect it, all right? Don't goof up like I just did. Any questions? All right, did I write your homework?